Okay, here we go. So I created a list for you guys, and I really wish I had done this since the beginning, and I did it now. It makes sense to me, so I hope it makes sense to you. I've kind of given you like a little list of reminders that you should always be looking at when you go to factor something. So when you are asked to factor and break it up into pieces that multiply, number one, we always look for a GCF first. Get the GCF out in the beginning, because in reality, it will leave you with a smaller, easier expression to factor, okay? If the expression leads with a negative sign, always factor the negative sign out with your GCF or as your GCF. So if your GCF was 2, factor out a negative 2. If you didn't have a GCF, factor out the negative sign. Factor out a negative 1, okay? And then step 3. I tried to visually put it as to how we factor, so I hope this makes sense. If you're going to factor a quadratic expression, ax squared plus bx plus c, then when we break it up into pieces that multiply, we know that whatever you put in the first 2 spots has to multiply to who up there? Somebody said it. Ax squared. It's got to factor to the first piece, which is ax squared, right? You know whatever you put in the front has to multiply to the first term, ax squared. Whatever you put in the last 2 spots has to multiply to who? C, yeah, the last number. And then we know our rainbows always have to add up to who? The middle term, bx. That is exactly how we factor. So I don't know if does that make sense?
Yeah.
It does. I think it does, kind of. So just to kind of give you a visual as to everybody's job, that is how we factor. All right, so let's do it. Let's do the hard ones. We are gonna work. All right. So what's gonna happen is, look at this problem. If I asked you guys to factor this expression, right? Break it up into pieces that multiply. First thing we're gonna do is look for a who? GCF. Does a 4x squared, a 16x, and a 15 have anything in common? No number, no variable. So when there is no GCF, make sure it doesn't leave with a negative. Does it leave with a negative? No, so we're good. So that means we just have to factor exactly the way it looks. So we're gonna start breaking it up into 2 pieces that multiply right away. All right, here's why today's problems are gonna be harder than before. We know whatever we put in this spot and whatever we put in that spot has to multiply to who? 4x squared. Guys, who multiplies to 4?
4. No,
4 and
2.
1, or 2 and 2. Now you have multiple options for the first piece. We haven't had that yet. Every single time I've asked you to factor, the front number has been either x squared, so we know xx. It's been 2x squared, so we know 2x1x. It's been 3x squared, so we know 3x1x. It's been 5x squared, so we know 5x1x. And then it's been 7x, where I think is the highest I've made you go, where we know it's 7x1x. Every problem I've had you do so far, the front number has been what we call prime, where the only factors are 1 in itself. So there was no guessing who it had to be. We knew it. Now, you're going to see problems where maybe you have options for the front pieces. So you're going to have to, all it does is add to the guessing and checking. You're really going to have to work those rainbows. So what I would suggest you do is, just like we always give ourselves options for the number in the back, let's give ourselves options for the front. What numbers do we know multiply to 4? So maybe it's a 4x and a 1x that get us the 4x squared, or maybe it's a 2x and a 2x. Okay, so I like to have my options. Now, let's continue on. We know whatever we put in the last 2 spots always multiplies to who? 15, and we're used to that. So let's give ourselves some options, 1 and 15, 3 and 5. And then the last thing we know is that our inside and our outside rainbows have to add up to who?
16x.
Negative 16x. Perfect. Guys, we got all the pieces. I'm going to kill myself. Sorry. So now, before I fall, now it's just literally, it's guess and check. Pick any factors of 4, pick any factors of 15, work the rainbows. Everybody put your pencils down. There is going to be way too much writing and erasing for you guys to bother with this right now. So let me do it. You guys just watch, and then all you have to do is write down the final one. Because all you're going to do is be writing and erasing. So just watch me. Let's say a lot of students in the beginning always do 4x, 1x, because they're so used to 2x, 1x, 3x, 1x, that they usually just always put 4 and 1. We don't know if that's them yet. We're going to try it. So let's guess and check 4x and 1x. So now you're going to guess and check 4x and 1x with all possible numbers that multiply to 15. And if nothing works, then you know it's not 4x and 1x. So it just adds to the guessing and checking process. All right, let's say we did, probably I would say you guys would do 3 and 5 first. Can I put a 3 here? Does he have a GCF? No, so we're okay. He could go there, 5 could go there. 3 times x is 3x, 4x times 5 is 20x. Are 3 and 20 ever going to 16? So it ain't that. So if you are able to mentally picture this without having to write and erase, then great. But otherwise, some students physically need to see it every time. All right, so before I roll out 3 and 5, let me switch them. Let me try 5 here. Let me try 3 there. What's 5 times x? 5x. What's 4x times 3? Are 5 and 12 ever going to 16? So we know it's not that. So if 4 and 1 are the numbers that multiply to 4, then it's not 3 and 5 because they didn't work in any way, shape, or form. So now you got to guess and check the 1 and the 15. So now we're going to try 1 and 15. Let's say you put 1 here, again, they don't have a GCF, and you put 15 there. What's 1 times x? 1x. What's 4 times 15? 60. Are 1 and 60 x's ever going to 16? Then it ain't that. So your last option would be to try 15 here and 1 there. And then you're going to get 15 x's and 4 x's. Are 15 and 4 going to 16? So now what you've just figured out is that 4x and 1x can't be the front numbers because they don't work with any numbers that multiply to 15. So now you're going to kick them out and you're going to lock in the 2x and the 2x. Okay, so now there's no other option. So now we know it has to be them unless you added wrong there. All right, pick your favorite factors of 15. Who do you want to try first, the 1 and the 15 or the 3 and the 5? Probably the 3 and the 5. Now, the beautiful thing about is a 2x and a 2x is, guys, your rainbows are both being multiplied with a 2x. So it won't matter where you put the 3 or the 5, and you're not going to have to switch them and try them in other spots because they're both getting multiplied with a 2x. So it cuts down on the guessing and checking. So in any order, 3 and 5. What's 3 times 2x? 6x. What's 2x times 5? Oh, baby. Could a 6 and a 10 get a 16? All right, now sometimes it looks like you have it, but then when you go to put the signs in, it don't work, and you got to keep guessing and checking. All right, can we make 6 and 10 add up to negative 16? And how do I make them add up to a negative 16, and then these numbers still multiply to a positive 15? Negative and negative. And then you're done. And then I would take that best 5 seconds and check. Does 2x times 2x get you 4x squared? Yep. Does negative 3 times negative 5 get you 15? Yep. Negative 6x, negative 10x, we got it. Now, guys, some of you are going to guess it on the first try. And it's like, wow, first one. And then some of you, it will be the last one every time. It's just the nature of guessing and checking. Sometimes you get it quicker than others. Now, to me, it's all in the rainbow number. Think about what you're getting your rainbows to become. How can I get that negative 16? And that's where I start placing things. But that's the process of guess and check. Guys, let me just tell you this. If I didn't teach you by guess and check, then the other method you would have to do means you'd have to take the first number, multiply it with the last number, get 60, find numbers that multiply to 60, add to negative 16, find them, put them with an X, pair them in the middle, group two, find GCF, make 2 factors. Nobody remembers it. This is why I'm very passionate about teaching you to factor by guess and check. The other methods, they take too damn long and they make numbers too big. So as annoyed as you might be sitting here saying, Carly, I can't believe how to do that. I'm telling you, the other methods are worse, all right? And you won't remember them. You'll be like, wait, who was I supposed to multiply to get started? Everything has a job here. We know this, all right? Let's try it again. Let's look at number 2. You have to factor that. You have to break it into pieces that multiply, right? First, you're going to look for who. Because, guys, now if I'm you, I see 6 and I'm pissed. And I'm like, God damn it, 6? Because you know it's not prime. So now I'm like really hoping for a GCF, so that's really not going to end up being a 6. So it makes me want a GCF, so I don't forget it. But unfortunately, does a 6x squared, a 5x, and a 4 have a GCF? No. Is it leading with a negative where I have to pull a negative out? No. So since none of that happened, we're ready to go. We're ready to start the factors. Let's give ourselves some options. We know whatever we put in the first 2 spots has to multiply to who? All right, who multiplies to 6? 3 and 2 or 6 and 1. It doesn't matter how you list them. I'm pretty OCD, so I always tend to list big number, small number. But but it really doesn't matter. If you put 2x, 3x, it still matter. All right, and then I know whatever I put in the last two spots has to multiply to who? -4 technically, but it's 4. 1 and 4, 2 and 2. And then I know my rainbows have to add up to who? -5x. All right, ready? Let's go. Pick your fate. Now I'm gonna do 6x, 1x first. You could do the 3x and the 2x. It's just a matter of maybe you get lucky and you pick the right ones. So if I did the 6x and the 1x, watch how nice this one actually winds up. If you can remember my tips. Guys, remember, we're always going to look for a GCF at the very beginning. And if it has one, we're going to take it right out and make this an easier, smaller problem to factor. So once you've established that there is no GCF, then none of your factors can have a GCF. So let's say you were going to check the 1 and the 4 first. If you're going to use the 1 and the 4, is 4 allowed to go there? No, because 4 and 6 have a GCF. So don't waste any time trying the 4 there. You would literally be wasting your time. So use that to know, oh, I don't even got to check that. I know it's not going to go there. Go ahead. Exactly. So we're going to get there. So now, if you try a 4 here, oh wait, before I do that, Paul, let me do what Paul just said. So Paul just said, does that mean it can't be 2 and 2? Guys, if you were going to try 2 and 2, can 2 go here? No, they have a GCF. And then you're like, oh, I guess I'll put the other 2 there. But wait, can I put a 2 here? No. So that means it's definitely not 2 and 2 because they would create GCFs. So the only options it could be if it's the 6 and the 1 is the 1 and the 4. And it's only if the 1 goes here and the 4 goes there. What's 1 times x? 1x. What's 6 times 4? 24x's. Are they going to a 5? So right away, you know, it ain't 6x and 1x. It's got to be 3x and 2x because 6 and 1 don't work with any numbers that multiply to 4. So again, that just saves you time. All right, so get them out of there. They ain't it. Let's lock in the 3x and the 2x. All right, now pick your favorite numbers that multiply to 4 and try them. However, the 2 and the 2. Can a 2 go there? No. And then I can't try the other 2 because it's still a 2. So who do you know it's definitely not going to be? It ain't 2 and 2. Don't even try them. So now we know it has to be the 1 and the 4. Is the 4 allowed to go here? No. So it's got to go there. And the 1 has to go here. Now let's see what we got. 4x, 2. 3 times 1 is 3. Oh, how do you make 8 and 3, add to a -5, but still multiply to that -4? -4. Yep, because that would make you -8, and then a +1 because that would give you a +3. And now double check. 3x times 2x, there's my 6x squared. -4 times +1 is -4. -8, +3, you got it. So yeah, it's annoying, but there are little tricks that if you can remember the whole, there was no GCF, so I can't create a GCF, it does save you a lot of guessing and checking. What's up? Okay, the problem is, if it had a GCF, if we did this correctly, Darian, we would have taken it out in the beginning. So when you take it out in the beginning, these still can't have them. The only time you could end up with GCFs here is if you forgot a GCF first. But if you're doing it right, you can take the GCF right out, and now these aren't allowed to have them, okay? And then if you missed a GCF in the beginning, and you were able to factor it, that just means somebody probably ended up with a GCF. So they have a GCF of 4, right? Of 2. I would take that 2 out, write it in front, and make that x plus 2. I don't want to confuse you, but that's all you would have to do to correct it. But if you're doing it right, you should always take the GCF out in the beginning, and then they are never allowed to have them. All right, I want you guys to try 3. Try 3. Get your options, look for a GCF, I don't have one, and then try and factor it.
Nice.
Oh, yeah, ones don't count. Yep, ones can go together. Because technically, everything has one as a GCF. Yeah.
Can I do that?
Nope, they have a GCF. So maybe it's not the 6 that's causing you trouble. What about the 8? What numbers multiply to 8?
Is this right?
Did you try them yet? I would try them. Yes, except what does he need? 8 what? 8 times what gets you 8x squared? Not a five. That sign's not wrong. Okay, what do you need to put with the 8? Good, perfect. Boom, done. How we doing, Brennan?
Something's off.
That's it. Oh, I like it. Keep going. I like that. I like that. Come on, Cole. Got it. Cole, you got it. Remember, couldn't put 6 there. 4 and 6 have a GCX. We already established there is no GCX, so you're wasting your time checking that.
I got it.
Yeah, I would use that. Those are definitely the ones you want. Okay. So now you're gonna guess and check numbers that multiply to 6, but don't put numbers here that have GCX with 8, because you're wasting your time. Did you do it, Stan? Yep. Wait, X and 8X. Yep, you're good. You're good.
Oh, wait, it's hard. I'm gonna, that's not gonna work.
Nope.
So that has to be squared, right?
So 8x times 1x gets you 8x squared. Negative 3 times negative 2 gets you positive 6, but your rainbows don't get you negative 49, so that can't be it. And keep the 8x and 1x.
All right.
Get rid of the 3 and 2. Who else multiplies to 6?
6 and 1.
6 and 1. Now don't you dare put the 6 with anyone that has a GCF, you'd be wasting your time. Okay. And that should cut down as to where you're allowed to put it.
Yeah, I didn't try 6 and 1.
I would try 6 and 1.
I didn't realize you could do that.
Well, that's the thing, and this is where I'm gonna sound, again, maybe I am just mean. I don't mean to sound mean. Some of you take 10 minutes to do one problem. If this is never gonna fly. Especially when I have to quiz you, and I'm probably gonna put at least 10 questions just to make sure you've seen a variety of factoring. And I will tell you guys, we are literally paused from Algebra 2 right now. We are just reviewing factoring. After we quiz, I'm gonna go back to chapter 4, the chapter we just started, and we're going to solve quadratic equations by factoring. So a factoring is just gonna be part of the solving process. You're gonna have to know to factor just so you can solve the question. So when you're taking very, very long, it just means you haven't practiced enough. Yeah. Done! Alright guys, give me it. So when you go to factor it, there was no GCF. Right? It did not leave with a negative, so we're just going to go right to our factors. We know whatever numbers we put here have to multiply to who? 8x squared. That could be 8x 1x or 4x 2x. Who was it? 8x and 1x. And then whatever numbers we put here has to multiply to 6. So that would be 1 and 6, 2 and 3. Our rainbows had to get us negative 49x's. Who was it? 1 and 6, 2 and 3. 1 and 6. Could 6 go here? No. So it would be 1 and 6. That's 1x. That's 48 x's. How do I get them to add to negative 49 and multiply to a positive 6? Negative, negative. Done. All right. Now, guys, if you ask me, that rainbow number is crucial. That's what you're trying to get your rainbows to. So I always look at the 49 like, all right, how can I fix this? Who's getting me the 49? That's what I concentrate on. All right. All right, so that is hard. Yes.
So you're only doing this and that, you don't go here and here?
No. When you check, the way it happens in FOIL, in FOIL you would distribute everything. Yeah. But after you've cleaned it all up, the first pieces always got you the first. The last pieces always got you the last. And it was your rainbows that got you that middle.
That's the part that I was struggling with because I was like, okay, 6 and 8 equals 48.
Mm-hmm.
But then how does that work?
That's how, yeah.
But isn't that negative?
Can you do? So, some people did this. As long as what is inside your parenthesis matches one of mine exactly, then the order that you write them in will not matter. This is just as right. Okay? All right, so those are the hardest ones. The good news is, guys, I've been teaching Algebra 2 for 17 years. I've been teaching pre-calc for about 15. The amount of times that they ask you to factor when it's a 4 or an 8 or a 6 or God forbid a 12, because he would have 3 options for the front, they just don't pop up as often as the 3s and 2s and 5s and 7s. So I just need you to notice that these ones are out here. I'm not going to put a super lot of them on the quiz, but just know that it's not always going to be this and this get me the first. Sometimes there's options for the first term, okay? All right, now that we've seen the hard ones, guys, go to the back, watch how easy these ones are. This is a special kind of quadratic expression, and it factors to a very special set of factors, which makes it really easy because there's no guessing and checking. It's just a set process. It has to be this, and it has to be that. So they factor much faster. All right, what you do have to be able to recognize is a perfect square. What is 1 squared? 1 times 1. 1. 1's a perfect square. What is 2 squared? 2 times 2. 4 is a perfect square. What is 3 squared? 9. 4 squared? 16. 5 squared? 25. Those are perfect squares because those are numbers that you can unsquare. There is a whole number that if you times together twice, you will get that number as your answer. So you just have to be able to recognize your perfect squares, and then that's it. All right, here we go. These ones will maybe take us about 5 minutes, and that's it for all of them. All right, if you are asked to factor the difference of 2 squares, it's going to be a perfect square subtract a perfect square. It is the difference of 2 squares. If you are asked to factor the difference of 2 squares, then they always factor to a plus b and a minus b. So basically, they factor to the same factors. One is positive, one is negative. So guys, if this is a squared, square root him, you need a and a. If this is b squared, square root him, get his b, you need b and b. So the numbers that you need are just a square root away. It's not going to take any guessing and checking. So watch this. If you are asked to factor these expressions completely, don't forget our first rule. Let's see. We have to factor this, right? We have to break it up into pieces that multiply. First, does x squared and 4 have a GCF?
Yeah. No.
No, they don't have a number in common, and they don't have a variable in common. So is it leading with a negative? No. So guys, you're ready to go right to his factoring. Is this the difference of 2 perfect squares? Is x squared a perfect square? Guys, he's x squared. He's a perfect square. He's x times x. Is 4 a perfect square? Yeah, he's 4. He's 2 squared. He's 2 times 2. So we can factor him into 2 factors. I need to unsquare these pieces. So I just have you guys do this. What is the square root of x squared? So I need an x and an x. They will multiply to x squared. What is the square root of 4? I need a 2 and a 2. And essentially what's happening, the first ones get me x squared. The last ones get me negative 4. And technically what's happening here is your rainbows have to add up to the 0 x's in the middle. You need your rainbows to cancel out and add up to 0. So what signs do I need to multiply to that negative and then add up to 0? Plus and minus. So there won't be any guessing and checking. If they are perfect squares, you're going to unsquare them, and those are the numbers you need in their factors. And it's always going to match. Whatever you put here will be the same there. Whatever you put here will be the same there. You just need opposite signs to make sure that your rainbows add up to the 0 x's in the middle. All right, look at this one. Let's say you were asked to factor that. First, look for a GCF. What does an x squared and a 9 have in common? Nothing. Does it lead with a negative? No. So then we're going to factor it just the way it looks. Is that the difference of 2 perfect squares? Yeah, x squared is a perfect square, 9 is a perfect square, and you're minusing them. Guys, if this was a plus, there is no sum of 2 squares. The sum of 2 squares do not factor. You literally cannot factor them into 2 pieces that multiply using whole real numbers. All right, so it only works for the difference. All right, let's see it. What's the square root of x squared? I need an x and an x. What's the square root of 9? I need a 3 and a 3. What signs do I need to make sure they add up to 0 x's? Plus minus. Done. Done. And the beautiful part is, guys, they pop up all the time in pre-calc. And it's like, oh, thank God, because they factor so easily and so quickly. All right? All right, look at this one. Is there a GCF between x squared and 49? No. Does it leave with a negative? No. So we're ready to factor it. Is that the difference of two perfect squares? Okay, so give yourself two factors. What's the square root of x squared?
Oh, wait.
Oh, no, XX, sorry. And then what's the square root of 49? 7 and 7, what signs do we need? Now, a lot of students are like, oh, I'm going to forget that negative, I know it. So some students always put the minus first and the plus second. Whatever works. It doesn't matter. As long as one parenthesis says x plus 7 and one parenthesis says x minus 7, you're fine. All right, you guys do 4. Factor x squared minus 36. Don't forget your steps. Look for a GCF, look see if it leaves a negative, and then you can go. You should be done. There was no GCF. There's not leading with a negative. That is the difference of two squares. So what two factors do you get? X.
6 and 6.
I need to know who, read them to me. What did you get? An X plus 6 and an X? Beautiful, right? We can factor it in two pieces. Give me an X and an X. Give me a 6 and a 6. Make 1 plus, make 1 minus. All right, let's step it up a notch. Why would we do that, Herdy? All right, we're not really, it's not that much. All right, look at number 5. If we had to factor that, we're going to look for a what first? Does a 4x squared and a 25 have anything in common?
No.
No, they don't. They don't have a number in common other than 1. We don't count 1. And they both don't have a variable. So there's no GCF. It doesn't leave with a negative, so we're ready to factor this. I'm not trying to sound like, I'm not trying to trick you. Is 4x squared a perfect square? Yeah, 4 is a perfect square, and so is x squared. They're both perfect squares. Is 25 a perfect square?
Yeah.
That's the difference of two perfect squares, so it counts. So we're going to break it up into two factors. What is the square root of 4x squared? A 2x and a 2x. And then what's the square root of 25? 5 and 5. What signs do I need to get to those 0 x's? Plus minus. So again, it might not just be x squared, but as long as everything involved is a perfect square, you're fine. All right? Problem. Look at number 6. Is 2 a perfect square? No, he's not. What can you square to get 2? Not 1 squared is 1. 2 is not a perfect square. People always think the square root of 2 is 1. A square root is not having something. A square root is asking what number did you times by itself twice to get to? Well, guys, 1 times 1 is 1. 2 times 2 is 4. What did you square to get 2? 1 point something. It's not a whole number. 2 is not a perfect square. He is a beautiful number. He's a beautiful, even, easy number, but he ain't no perfect square. So this is not a perfect square. Is 32 a perfect square? No, 5 squared is 25. 6 squared is 36. We skipped right over 32. It's 5 point something. So that's not the difference of two squares. But I'm not worried because what do you always look for first? What does a 2x squared and a 32 have in common? Take a 2 out. Now, guys, for whatever reason, some people are saying, yep, the GCF is 2, and then they're doing this. You're not ready to factor yet. You have to show me what is the leftover expression once you take a 2 out. You're not ready to break the whole thing up yet. So now 2 times what gets you? 2x squared. 1x squared. 2 times what gets you? Negative 32. Negative. Ooh. Is this the difference of two squares? Yeah, x squared's a perfect square. 16's a perfect square, so bring your 2 down. And now let's factor our perfect squares. What's the square root of x squared? Xx. What's the square root of 16? And what signs do we need? Plus and minus. So it might not start out as the difference of two perfect squares, but once you remove a GCF, you could be left with the difference of two squares. All right. Now, before I do the last one, for whatever reason, Delta Math likes to do this. we had what? X squared minus 36 before? Delta Math does this. Now, I'm not trying to trick you. That was the difference of two perfect squares. Is this the difference of two perfect squares? It is. Perfect square, subtract. So when you go to factor this one, what's the square root of 36? 6. What's the square root of x squared? X, and then what signs do we need? So it can work out like that, and that's perfectly fine. And ultimately, that's all Delta Math wants you to do. I didn't want you getting thrown off by that, so I tried to leave those ones out. But that is the difference of two perfect squares. The problem is, when we get the pre-calc, we teach you to take this, rewrite it as negative x squared first, plus 36 second, factor out the negative sign, and now factor the difference of two squares. This is doable. This is fine. But I just didn't want you guys getting thrown off, so I just weeded them out. But just know that could happen, and it's fine. It doesn't matter the order as long as they're subtracting two perfect squares. But you have to make sure that you put them in their factors in the same order they were written in the problem. All right, look at the last one. Is that the difference of two perfect squares?
No.
3 ain't no perfect square, guys. That's x to the third. He definitely ain't a perfect square. That's okay, because what do we always look for first? Okay, what does a 3x to the third and a 3x have in common? Definitely a 3, and what else? An x. And since it led with a negative, what should we factor out? Negative 3x. All right, now what's left? Now remember, you have to make sure that whatever you put in here, this times that gets you back to the original. Negative 3x times what gets you back to a negative 3x to the third? X squared. Negative 3x times what gets you back to a positive 3x? Somebody said it?
Negative 3.
Nope.
X. No,
Negative
negative 3.
1.
Negative 1.
Oh, negative.
Just got to get back to itself, right? So now, and I'm not trying to sound tricky, is that the difference of two squares?
Yes.
Yeah, 1 is a perfect square. He's the best one. 1 squared is 1. He's the best one. All right, so now we're going to drop negative 3x down. Factor that again. This is the difference of perfect squares. What's the square root of x squared? X. What's the square root of 1? 1 and 1. What signs do we need? You're done. I like that because, guys, nobody ever believes that 1's a perfect square. 1 squared is 1. The square root of 1 is 1. So he is the first perfect square, so don't forget that. All right, you're good. So, guys, I did create a homework on Delta Math. It's 10 questions. 5 of them are perfect squares, so hopefully they're really quick. And then 5 of them are not. They're just normal factoring problems. I just have to warn you. I had to hand pick tonight's problems from Delta Math, so I wanted specific ones. So it's not going to be an assignment where it just keeps giving you more problems if you get them wrong. There's 10 questions. You get 3 tries on each question, and it just marks you wrong. It's not going to give you another one. So you have 3 tries to get them right. Otherwise, you lose the problem. Okay? So I apologize. Hopefully by the third one, though, you'll get it. And then don't forget, yesterday's homework on quiz is due tonight.
Do your card,